let's get rolling. We got a 10-meter building. We got a 10-meter building being added to a problem. So we've got ourselves a problem, an equation, a formula, and they're just adding a 10-meter building to it. So what if you had to guess, and we're starting with it, what type of shift makes a ball get thrown from 10 meters in the air? Probably vertical, right? So if we're thinking about the original situation looks like this. Yeah, throw a ball, right? And what does the new situation look like? Yep, you don't even have to know math. You don't have to know all the equations. You don't have to know nothing. It's just the same guy, but now he's 10 meters up with the ball, and he's going to throw the same ball. Cool. So what might this equation end up being based on the thing that we've learned today? Any thoughts? Just plus it. We're going to take the old ugly equation, which if you've seen gravity, happens to be gravity. And if you've taken physics, it happens to be a kinematic equation with Earth's gravity. But instead of throwing it from the ground, we're adding a building to the whole thing with a plus. Time. T is the most common independent variable in the world. Why? Time is a pretty common plug and chug. All right. So we just plus 10. We're allowed to do that. If he would have thrown it, if the problem would have said he climbed to the bottom of a pit and threw it, you know what you would have done? Boom. There you go. That's it. If you had to draw the picture, you take the original plot, which this is very hard to originally plot because of the decimal and everything. We wouldn't ask you to do something like that. But you take the original plot and you just go up 10 and replot it. Done. All right. We did 1. Check mark. We're going to do 2 as well, just because it's a graph and it's a different type. And then we'll skip all the way to 5, and then we'll go to the last one and be done. Oh, shoot. You've been given a function. From day 1, I told you there's functions you need to know what they look like. Any thoughts on what that function looks like? What? The square root function? Oh, no. Breaks my heart. Good job, Dia. Yeah. If you don't know, that's a fun way to remember it. I just remember what? Yeah, I did. Yeah. If you don't remember plug and chug points, if you plug 0 into the square root, what does it look like? Or what's the number? Yeah, so we got 0, 0. If you plug 1 into the square root, what do you get? That's the number. If you plug 2 into the square root, what do you get? Yeah, don't even bother. Skip to the good number. What's the next good number? If you plug 4 in the square root, you get 2. And if you plug 9 in, you get... That was on the functions you need to know page. It's a sideways parabola. It's a what'd you say? Which one? Oh, sorry. I can. This is a long page. I just trimmed this page from like 10 down to 3. And I was trying to, and part of the sadness of that was the graphs got real small. Nah, it's all right. But we're actually going to do something to this. What are we going to do to it? Which way? To the left? 2? No, not going to do it. Going to refrain. We're going over 2, right? So just take every single dot and move it over 2. And then connect your dots. Not too bad. That would be root of x plus 2. Did they call it f and g or something or like that? Probably. F of x and g of x is what they usually do. Not too crazy, huh? That's the crux. That's like what you really, really, really need to know. Like, you need to be able to do those two things. The next thing is like, okay, you need to be able to do it, but there's some trickiness involved in it. So let's hop all the way down to 5. Oh, no, 5 is not tricky. 5 is straight up exactly what it is. But it's because I wanted to show at least one reflection, because y'all mentioned, both groups mentioned it. And it's like, okay, we got to at least do one reflect. And it gives us a chance to practice another function you need to know. Yep, that function right there. What does that look like? It does look like a V, except for what? Based on what we just learned 2 seconds ago. To the right by 1. So it's a normal style V, just to the right by 1, right? And I plot a few points, and then sometimes you can grab your ID if you're in high school or you're something else and just draw the line. Plot a few points, draw a straight line. I don't have anything. I thought I would have something to draw it with. Ah. Nope, don't do that. No, that wasn't even that good. Cool. But what are we supposed to actually do with it? It says reflect vertically. So you know what it does? And you're done. Yay, we did it. Though we should probably write the equation. F of x. Oh, let's call it g of x. G of x is equal to, where does a negative sign go? Where does a negative sign go if it's getting reflected vertically? Yeah, right out front. Big negative sign right out front of the whole thing. Everything that was once positive became negative. Now the horizontal one is a little more annoying, but we can do it. X minus 1, I'm just going to redraw the graph again. It is really hard to draw. I should get a line tool. Watch this. This is going to be fun for me. A line. Where's the line? Anybody see a replace tool? ... Replace. Replace with a line. An arrow. Ooh. What? Can I do that? Let's see if this works. What? Bet y'all didn't know I could do that. It's because I also didn't know I could do that. But I'm pumped now. That just changed the game for math. I can draw arrows now. So that's the absolute value function shifted to the right one. Cool with that? So what happens to every single point? What does every point get to do? Like that? That one stays the same? So it's going to look like that pretty much. Basically turns into a left shift. It's not actually, but. Y'all, this is a game changer for the math teaching world. I had no clue I could do this. That's amazing. So we flipped it across this green line, right? So every point basically just reflected across it. If you wanted to look at it pretty cool, it'd be like, If you go way over here to the very top, it better end up in the exact same spot. Like that. See how that top ended up right there and that top ended up right there? It's a perfect reflection across the line. And where does that negative sign go? This is the hardest part of the whole thing. Where does that negative sign go? G of x, the red one, right? G of x is equal to, it was the absolute value of x plus 2, right? Was it plus 2 or minus 2? Oh, I don't know what. I'm sorry. Where is this newly introduced what the 20? Where is this newly introduced negative sign going to go? Right here? Right up next to that x? And we're going to throw parentheses around it so we don't accidentally open that 1. That's the scary part is you want the instructions didn't tell us exactly where to put it. They said, hey, put it on the inside, right? It goes right up against that x. We don't want to include the 1. Now, if you want to factor out a negative now, turn it into a plus 1, you totally could. But that's, I think, where this thing needs to end up. Plug and chug some points. I don't know, just to make sure it didn't mess up. Then it. Sometimes when I'm working through these shift things, at the end of the whole thing, I'm going to plug and chug some points because it's real easy to make a mistake. Like, so easy to just miss a negative sign or forget to distribute a negative sign or distribute when you shouldn't have. I do it a lot, like pretty darn often. So if I just plug in 0, so let's say our new equation is this. G of x equals negative x minus 1, right? So just plug in 0. What do you get? G of 0 is? I'm plugging in 0 to see what I get. I'm just checking my work to be careful. 1? Because the absolute value. It was negative 1 and then it turned into 1 absolute value. Is that a point on this graph? 0, 1? Okay, cool. Let's plug in at least 2 more. Maybe just 1 or 2 more. G of, let's say 2 is? Negative 2 and then negative 3 and then that turns back into positive 3? Is that a point on our new graph? The new graph is the red graph. It seems to be. The last one, I'm going to go to the other side. I'm going to try the x-intercept just for fun. G of negative 1 is? Negative 1 turns into positive 1. Minus 1 turns into 0. Cool. We did it right. Awesome. The negative sign goes right up next to the x value. It doesn't go on the whole inside. It goes right up next to that x value if you're reflecting. Cool? All right, one more problem, I think. I need to take a pause, actually, before we do the last one to just mention even and odd. I think we're going to get to it again. I don't remember the whole curriculum for this class, exactly like where everything is. I'm pretty sure we do a whole day on odd and even functions. I just can't remember. I saw it there last hour. I was like, crap, we got to stop here. It won't take long, I promise. I know it's been 15 minutes, and I told you it was going to be 15. Even means even. What's the most basic even number in the world? I think so, yeah. So think of x squared. And you know what x squared is that's really, really pretty? X squared is symmetrical. And that's what even means, symmetrical across the y, I think. See that? So if you're ever like trying to remember and like, I don't remember even, odd, whatever, most basic even thing in the world is x squared because it's got that squared. It's symmetrical. Boom. Even easier to remember odd because odd and origin start with the same letter. So that's pretty nice. The word odd starts with an O. The word origin starts with an O. Odd means symmetric about origin. Think of the most basic odd function in the world. y equals, I think 1. But you could do 3 too. They're both going to work. Y equals x looks like this. You know what you could definitely do? Take every single point, reflect it across the point that's the origin, and it ends up on the line again. Same thing for, someone said 3, right? Someone said 3? Yankee? Same thing. If you do it with 3, if you take any random point and you beeline it for the origin in a dotted line like this, you know what happens when you do that beeline again? Look at that. You end up back on your graph. That's what origin symmetry kind of means. I know it's a new concept compared to perfect x and y symmetry like back in geometry. But origin just means take any point, go straight to the origin, and then if you keep going, you should end up on the graph. Okay? So then, just a real quick check. Even or odd is 4. Is 4 even or odd? Is 2 even or odd? Oh. There's nothing there. I'm pretending. I think there is something there. Is what 0? Is what 0? No, I'm saying there's nothing here to look at. But I propose that there is something there. I propose to you there is a variable there. What variable is there? That's a number, not a variable. I propose that there's a variable there. It is S. 7, that's funny. S to the 0 power is just 1, right? And now we can keep our pattern going. Is 0 even or odd? Even. Oh, look at that. So you know what that function is? Even means? Even. You know what odd means? Odd. Or origin symmetry. And then you know what a mix of the two means? It's one of the options up here. Odd would mean all odd. And then you know what neither would mean? Few of both. When we come back to evens and odds, we will actually use these formulas up above that you could plug and chug the negative x to c. But for now, I just wanted to do a brief introduction. Even, odd, look at the exponents. All right, last but not least, let's go all the way to the end of the thing. We're going to do one big transform. We're going to do one big transform with all the transforms that we talked about in the first hour, and then we'll be done, and I'll turn you loose. So here we go. What transforms do you see happening? What's the easiest one? Did y'all just grab that from the paper? Yeah. That's cheating. Cheating? We didn't know we were doing this. -3 means you're going what? Down 3? Okay. Ooh, no. We have the sneaky thing happening here that I said we need to be careful about. Before you can just start pointing at things, we need to get the x kind of a little simpler, or we need to get it more isolated, or we need that 1/2 to affect everything. So what we're going to do is we're going to factor out a 1/2 so the x is by itself. We want that x to be by itself. We want the f to be by itself, so we're going to have f of 1/2. And if you factor out a 1/2, what are you left with? X. Well, hang on. You got to factor out a 1/2 of here, too. And if you factor out a 1/2 out of a 1, what do you end up with? I know the two temptations are 1/2 and 2. So you know what we're going to do? We're going to reverse distribute to know which one to do. You distributed property that, does it give you the first term? Check mark. If you distribute property again, what's going to get you to have a 1 as your answer? Well, there you go. Or, if you don't like that, think about this. What's 1 divided by 1/2? Keep, change, flip. You end up with 1 times 2. Doobie-doobie-doop. So that's that. We need that -3. And now we know all of our shifts. You need it in that form. You have to have it in that form to know all the shifts. That's all the shifts. Down 3. To the left 2. Ooh, what's the 1/2 mean? 2 times as skinny or as wide? Wide, because it's inside and it's flip-flop. Okay, on the paper, they give you the option to not do that. Up above, see the 2 section right there? The number 2 rule? If you have it in this form, they say, you don't have to do that. Just memorize this rule where you're actually going to shift first, which we don't do, and we're about to learn that. And then stretch, but you have to remember h over b and 1 over b instead of just the things that are there. So I just cross out 2. No, we're not doing that. I would not like you to memorize an extra rule. We're just going to we're going to do what we just did. Factor it out, get x by itself every time. Get x all by itself every time. It's way prettier, way cleaner. All right, so now we're going to shift it up and down, right? So we're going to start by shifting it down. How far down is it going? 3. And then somewhere up above, it tells you whether to do shifting horizontal or shifting or stretching first. Which one are we supposed to do first? So that was the down 3. Somewhere up above on that paper you're looking at, it tells you shifting or stretching first. For both of them, it's the same. For horizontal, cross out 2. I told you to cross out 2. Cross out 2. That's why I don't like 2, is because it's saying, hey, in this one condition, flip which one you do first and also remember an extra division. You see you know what I'm saying? Instead of that, just get x by itself, and now it's the same steps for both of them. It's way better. So we stretch first every time. Stretch first. You get to shift first if you follow number 2's rules. I'm asking you to cross out number 2. I typed it from the book. It's in the book. It's true. It's just harder to remember, and it flips the order of things if you can remember to flip them and do h over b instead of just h. So we said it's going to be twice as wide, right? Right? Or 3 times as wide. I forgot the number. Twice as wide? So what's twice as wide as 0? I'm just going to do one. Yeah, I'm just going to color at a time. What's twice as wide as 0? If I'm 0 wide and I get twice as wide, how wide am I now? No, 0. If I'm 0 wide and I get twice as wide as that, if you got no money and I double your money, how much money you got? No money. If you got 0 money and I say I'll double your money, you know how much money you got? No money. Yeah. So if you're 0 and I say twice as wide, you're not going anywhere. Now if you're 2 wide, if you're -2 and I go twice as wide, you know where you end up? -4 and +4. Oh, what am I doing? Thank you. Oh, I did 5 on both of them. That's so dumb. Okay, so that's our stretch. That should have been a 1/2 on the inside. Is that what it was? Or was it a 2 on the inside? Yep, 1/2 on the inside. Yay. I was not wanting to scroll over. That's 1/2 on the inside. And then the last thing it tells us to do is probably horizontal shift, right? So which way are we going? To the left. How many? So, nice. Right on the end of the graph. So just take every point. There are our 3 shifts. Cool? I know it's a lot of work, but that's why I want you to practice, do some homework right now in class. That was our 3 shifts in order. Down 3, stretch, move over. Now we didn't have a vertical stretch, but do you know when we would have done it? We didn't have a vertical stretch. We could have. We didn't have a vertical stretch. Do you know when we would have stretched it vertically? Oh, I was hoping you would. That would be hard to do at the very end. So we did horizontal stretch, then horizontal shift, right? We did a vertical shift right here as in green. So when would we have done a vertical stretch to make it taller if we were going to stretch it vertically? I think, does it say up above? Pretty sure it says. Yep, start at the very beginning. When combining verticals, first stretch, then shift. So the very, very beginning, just go vertical and then shift. And then right after that, go horizontal and shift. Now that stretch could be a compression or a stretch. I'm not saying it's going out. So you start with vertical, then, nope, that's wrong. Vertical, move it. Horizontal, move it. Done. Call it a day. Cool?